This is the 5th vodcast for Unit 5 covering percent composition. This is B-level work. All percents follow the same basic structure. Okay, it's the part you're looking for over the whole thing times 100%. In this case, the percentage is the unit, not the percent key on your calculator. So what you want to do is you want to find the mass of each of the components, the elements involved, and then divide by the total mass of the compound and multiply by 100. So really simple setup there. So let's take a look here. You want to calculate the percent composition of a compound that is 29 grams of silver with 4.3 grams of sulfur. So since it doesn't specify in terms of percent composition, we want to figure out the percentage of each element. So let's do silver first. So the part we're looking for, 29.0 grams, divided by the whole thing, well, that would be 29.0 grams plus 4.30 grams times 100 is our problem. Okay, so 29 divided by 29 plus 4.3, okay, times 100, and you get that your compound is 87.1% silver. Now at this point you can do the same process for sulfur. 4.30 grams of sulfur divided by 29.0 plus 4.30 grams times 100. Or you can recognize that all percentages have to total 100. Okay, so all your parts must total 100. And you should still get the same answer, maybe a slight variation due to rounding, but we get 12.9% sulfur. Okay, so that's all percent composition is. So we can also get it from the formula. You assume you have 1 mole of the substance, and if you assume you have 1 mole, then you know the mass of the pieces and the whole, and you use the values from the periodic table. Okay, calculate the percent composition of C2H4. So what we do is we take the masses off the periodic table. You've got 2 carbons, and carbon has a mass of 12.01. So that's 24.02. We've got 4 hydrogen. Hydrogen has a mass of 1.01 for a total of 4.04. Add them up. Our whole mass is 28.06. If you outline it like this, it's really simple to solve the problem then to do the percent composition. Let's say we want to do the percent composition of carbon first because it's listed first. So we have 24.02 grams of carbon divided by the mass of the whole thing, C2H4, times 100. So 24.02 divided by 28.06 times 100, and I get, well, I should have my answer in 4 sig figs, so that should be 85.60% carbon. And then I've got 4.04 grams of hydrogen divided by 28.06 grams, my whole C2H4 times 100, and multiply and divide on your calculator. And this time I should only have 3 significant figures, so that's 14.4% hydrogen. Okay, pretty straightforward stuff. Alright, one last one here. Calculate the percent composition of aluminum carbonate. So you had to learn how to name things. Let's put together aluminum carbonate. Al. Al's got a +3 charge. Carbonate, I know from that 8 ending, is a polyatomic ion. CO3, -2. Well, that means my formula will be Al2 CO3 3, like that. So if we want to calculate the percent composition of aluminum carbonate, we've got 2 aluminums, and aluminum has 26.98 for its mass, for a total of 53.96. I've got 3 carbons. Carbon is 12.01 for a total of 36.03. And I have 3 and I have 3 times 3 for 9 oxygens times 16.00 for a total of 144.00 for the mass of the oxygen. Add these all together, and I get a total mass of 233.99 for the total grams per mole for aluminum carbonate. And then all I have to do is take that 233.99 and divide it by each of the parts. Again, you can see when I put it in a list like this, it makes the math a lot easier. It also kind of sets you up for the pattern for a little bit for the A work. If you can handle the percentages on the B work, you should definitely check out the A work. It's not that challenging, it's just taking it one step further. So I have 23.06% carbon. Oh, percent aluminum. That's not carbon, that's aluminum. Percent aluminum. See, you should always know what you're dealing with there. And then now my carbon is 15.40% carbon. And then my oxygen, multiply it through, I have 61.54% oxygen. And if you add all these up, you should total 100%. You might get 99.99 or 100.01, but that's just due to rounding errors. It still should be about 100% there.